Since its launch in December 2021, the James Webb Telescope continues to provide breathtaking images and unprecedented insight about the celestial beyond. From stunning exoplanets to galaxies far, far away, the $10 billion telescope has become an integral instrument for space exploration. These are 10 mind-blowing discoveries from the James Webb Space Telescope in 2023. These images, captured by the telescope, reveal things scientists can't explain. Astronomers spent 50 hours peering into the deepest cosmos and spotted some of the first galaxies ever formed, well over 13 billion years ago. Capturing such a rich cosmic vista with the faintest objects humanity has ever glimpsed is an impressive feat. But the data also reveals that these primeval galaxies emitted a phenomenal amount of energy into space, 10 times more than scientists predicted. Astronomers aren't sure what could have created these extreme outbursts of energy, specifically ultraviolet energy. It could be young, lively stars, way hotter than our medium-sized sun, emitting bounties of energy into space. Or it's possible this ancient light was created by supermassive black holes, which are objects hundreds of thousands to billions of times the sun's mass and are usually found at the center of galaxies, like our Milky Way. On left, a deep field view of the cosmos with vivid spiral galaxies in the foreground and a plethora of much older galaxies in the distance. Pretty much all these objects are galaxies. On right, zoomed in views of 3 of the highly redshifted galaxies releasing unexpected amounts of energy. A statement about the research explains they would have been formed in the first 200 to 500 million years after the Big Bang, when the universe's age was 1 to 5% of today's age. The rocky worlds of the TRAPPIST solar system have captivated scientists. Until recently, these Earth-sized planets beyond our solar system, called exoplanets, have remained largely mysterious. But researchers suspect some could host water, and maybe even conditions suitable for extraterrestrial life. With the power of the James Webb Space Telescope, astronomers can analyze these worlds in unprecedented detail. So far, Webb has viewed the 2 closest planets to their star, TRAPPIST-1. In the case of TRAPPIST-1c, located some 40 light-years away from Earth, astronomers used a clever strategy to sleuth what is or isn't in the atmosphere. They watched the world pass behind its star 4 times, allowing researchers to compare the total brightness when the planet was beside the star, TRAPPIST-1c plus light from its star, versus just starlight. This let astronomers determine how much of a certain type of light, which is absorbed by CO2, was present on this extraterrestrial world. Ultimately, they found little evidence of CO2. There are more TRAPPIST planets to explore with Webb, and astronomers highly anticipate what the telescope will reveal. Taken during instrument calibration, this image helped test Webb's ability to dig up galactic fossils. This galactic image shows a deep view of the cosmos that other telescopes can't see. The universe's most ancient galaxies are so far away that their light has literally stretched out into wavelengths that aren't visible to our eyes. In the foreground, near the bottom, is a glorious example of a spiral galaxy called LIDA 2046648. At around 1 billion light years away, it's much closer than the distant galaxies beyond. Our Milky Way is a spiral galaxy too. Everything else in this image is a galaxy, except for the 6-pointed objects, which are much closer stars. Bright points of light in a telescope like Webb can cause something called diffraction spikes. Many of the distant galaxies look reddish or orangish. As the universe expands and these celestial objects move farther away, their light has stretched. There are few places in our solar system more intriguing than Europa. Beneath its cracked icy shell, NASA and planetary scientists suspect this Jupiter-orbiting moon harbors a giant sea, some 40 to 100 miles deep. Now, observations from the James Webb Space Telescope show a region on Europa's surface contains carbon dioxide, an important ingredient for life as we know it. The find isn't nearly evidence of actual life, but it makes the ocean world an even more compelling place to further explore. The 3 images on the right show where the Webb telescope identified carbon dioxide on Europa. The white regions at center right depict the carbon dioxide-rich Terra Regio area. This cosmic photo, captured by the telescope, shows a cluster of galaxies around 6.3 billion light years away. The cluster of galaxies, called SDSS J1226 plus 2149, holds so much star and planetary weight that it's literally warping space, like a bowling ball sitting on a mattress. The warped cosmic area distorts and magnifies the massive objects in the distance. This effect is referred to by astronomers as gravitational lensing, and it occurs when a massive celestial object, such as a galaxy cluster, causes a sufficient curvature of space-time for light to be visibly bent around it, as if by a gargantuan lens. In the lower right area, you can see poignant examples of distorted light caused by warped space-time. These are the red elongated shapes. In particular, there's a red, long, bright, and distorted arc spreading out near the core. NASA calls this object the cosmic seahorse. Such powerful magnification allows scientists to peer into this galaxy and grasp the star formation inside this distant realm of space. It might look puny, but this pink object is awfully powerful. Scientists captured a rich image teeming with some 20,000 galaxies. At the center is one of the most brilliant objects in space, a quasar, which is a supermassive black hole at the center of a galaxy that's feasting on bounties of cosmic matter and releasing outbursts of energy as it shreds apart and eats. That's why such an object is millions to billions times brighter than the sun. The quasar is directly at the center of the image. It appears pink and has 6 diffraction spikes, caused by how the object's radiant light hits the Webb Telescope's 6-sided mirror. The extremely distant quasar is ancient, at around 13 billion years old. NASA said that light from these distant quasars began its journey to Webb when the universe was very young and took billions of years to arrive. In the foreground are bluish stars, also with diffraction spikes. Everything else is an entire galaxy in deep space. You're also seeing them as they existed billions of years ago. Astronomers pointed the telescope at the galaxy NGC 5068, peering deep into its starry core. The greater goal is to better grasp how stars, like our energy-providing sun, form and evolve in galaxies. Crucially, Webb views a type of light that's invisible to the naked eye called infrared light. These long infrared light waves pierce through thick clouds of cosmic dust and gas, allowing us unprecedented views into galactic hearts. The radiant white bar is the galaxy's core. Similar to the Milky Way, NGC 5068 is a barred spiral galaxy, meaning it has a long bar-shaped structure at its center, which is composed of densely packed stars. All those bright dots, both in the core and populating the image, are stars. Many thousands are visible. And though we can't see them, many of those stars almost certainly harbor wild, exotic planets. On the right is a curving spiral arm of the galaxy. In our galaxy, Earth inhabits the farther reaches of a spiral arm. The ESA explains the general skeletal-like structure in the galaxy is made from colossal clumps and filaments of dust. Pictured here is one of the nearest galaxies to us, NGC 6822. Also called Barnard's Galaxy, and it's a stunning sight packed with an uncountable number of stars. This local galaxy is relatively close at some 1.5 million light years away, allowing the Webb Telescope to see such stellar detail in this galactic close-up. Almost every spot or dot you see in this image is a star. The brightest stars are shown in cyan or pale blue, while the farther away stars are seen in warmer colors like orange, yellow, and red. At left center in the image, to the left of clouds of reddish gas, is a bright blue orb. This is a large cluster of stars called a globular cluster. If you peer closely, you can make out tiny galaxies in the distant background of the star field. For example, one is a spiral galaxy located near the top left corner of the image. Ancient Mayan culture referred to the Orion Nebula as the cosmic fire of creation. Contemporary scientists see that enormous cloud of gas and dust in space in a somewhat similar way. The vast baby star nursery south of Orion's belt is about 1,350 light years away, making it the closest large star forming region to Earth. Because of its proximity, it's a prime target for astronomers to study the births of stellar objects. Now, scientists are able to see this important celestial site with unparalleled resolution. A European Space Agency tool known as ESA Sky allows users to zoom in and explore details. Some 2,400 individual images were combined to make the full short wavelength color composite view, and 712 individual images were combined to obtain the long wavelength one. In the year 1054 CE, astronomers saw a strange bright light appear in the sky. We now know it was a star's explosion, a dramatic event called a supernova, which was visible even during the day for some 3 weeks. Today, the glorious remnants of that exploded star exist as the Crab Nebula, and scientists were able to capture an unprecedented view of the iconic object. At the center of the cloud of dust and gas is a particularly bright star. That's the core left over from the stellar explosion in 1054 CE, from a star many times more massive than our medium-sized sun. It now exists as a profoundly dense type of neutron star, an object so incredibly dense that a teaspoon of neutron star weighs around a whopping 1 billion tons. This object is also rapidly spinning, some 30 times per second, making it a neutron star called a pulsar. A milky smoke-like material winds through the nebula. These are charged particles created by the quickly rotating neutron star swirling through the star's magnetic field. The expanding cloud of material around a star is largely composed of ionized sulfur, seen in orange, and dust, seen in yellow-green.